Okay, here's problem two. Kind of a lot to fit in on this screen, but I'll do my best with it. Dealing with complex numbers in polar form. So first we have negative 3 plus 3i in the form r e to the I theta. So we need to find the r and find the theta. The r is just like the Pythagorean theorem, and so I know that r is going to equal the square root of the real part squared plus the imaginary part squared. So that means that r is equal to the square root of 9 plus 3. R is equal to square root of 12. Um, you can go ahead and keep it in that form. You could also use the exponent of a half. You could try also to pull out the 4 to make it 2 root 3 if that makes you happy. The angle can be found by using the inverse tangent of that. And so if you want to think about it this way, let me back up a second. When I have a complex number, the tangent of the angle is equal to the y value over the x value. So I'll say the tangent of theta is equal to the y value, which is the imaginary part, divided by the x value. And this is equivalent to, if you looked on your unit circle, this is equivalent to 1 over negative square root of 3, which is also equivalent to 1 half over negative square root of 3 over 2. And the reason I made it that way is just because I'm looking for some of those coordinates on the unit circle. And I know as well that this complex number here is in quadrant number 2 because the x value is negative and the y value is positive. And so that kind of helps me figure out what sort of angle it should be. And so that would be 150 degrees. Or if you if you do the inverse tan on your calculator, it's actually going to give you the angle in quadrant 4. But in quadrant 2, you can just add pi to that angle. So it gives you 5 pi over 6. 5 pi over 6. Because 5 pi over 6 has a sine value of a half and a cosine value of negative square root of 3 over 2. And so we can express it in the form required, negative 3 plus square root of 3i is equal to square root of 12 times e to the I theta, 5 pi over 6. Everything looks good. So now we're talking about the roots of that equation. So we have z cubed equaling that original value. So we need to find u, v, and w, expressing our answers in the form r e to the I theta. So what I know is that u to the third power is equal to this, v to the third power is equal to this. So we have 3 different values that are equal to this. And one thing that you need to keep in mind is that you can always add 2 pi to a complex number, to the angle of a complex number, and it will be equivalent. And so what I'm going to set is that u to the third power is equal to square root of 12 e to the I 5 pi over 6. And if I take the third root, then I get, instead of the square root of 12, I get the sixth root of 12. And instead of 5 pi over 6, I get 5 pi over 18. You had a little clue, by the way. A lot of times these problems have clues. You have a clue down here. You see how there's a 5 pi over 18 in that part D. So that's my u value. Now to get the v instead of the u, so this is my u, put a little tail on it. To get my v, I'm going to add 2 pi to my original angle. So let's move this to the side. Okay. So I'm going to add 2 pi to my original angle. So v is going to be v to the third power is square root of 12 e to the I. If I add 2 pi, that's like adding 12 sixths. So 17 pi over 6. That means that v is going to be 12 to the 1/6, 1/6 e to the I, 17. Okay, let's try that again. Handwriting got a little rough. E to the I, and it's going to be 17 pi over 18 because you divide the angle to take a third root. So I 17 pi over 18. Similar idea for W. So W to the third power is square root of 12 e to the I times 29 pi over 6. And then taking the third root of that leaves me with 12 to the 1/6 e to the 29 pi over 18. Now you might have noticed that here was our angle for U on part D, and then here is our angle for V, but we got, instead of getting the 29 pi over 18, there's a 7 pi over 18 on part D. So that's a little bit of a clue that something is weird here. And if I look back at my instructions, my angle needs to be between negative pi and positive pi, and this is not. So what I can do is subtract 2 pi from it. So an equivalent form for W, if I subtract 2 pi, would be 12 to the 1/6 e to the I. And if I subtract 2 pi, that's like subtracting 36 pi over 18. So it's 29 minus 36. I have negative 7 pi over 18. And that looks a lot like the cosine of 7 pi over 18. So I have my values. Let's circle all the answers here because I'm going to have to clear things to do the next several parts. So there is 1. Here is the U value. Here is the V value. And here is the W value. And I'm actually going to pause this, stop this video and pick up with a fresh video for parts C and D because it might just get too long otherwise. So we'll pick back up in a second with parts C and D.